Good morning, students. Myself, Vijay Shankar from IIECE Department, Chippewa Engineering College. Today, we are going to discuss about the examples in Laplace transformation. A damped cosine wave is given as f of t is equal to e power minus at cos omega t. A damped cosine wave is given as f of t is equal to e power minus at cos omega t. Find out the Laplace transformation of this signal. So about the Euler's identity or Euler's theorem, cos omega t is e power j omega t plus e power minus j omega t by 2. And it is multiplied with the negative exponential e power minus at. And it is multiplied with the negative exponential e power minus at. So multiply this e power minus at with this cos omega t exponential values 1 by 2 into e power. For these two are bases are equal, we can add the powers here. Minus of a minus j omega into t plus e power, both are it is a minus, take the minus a plus j omega into t. But taking the Laplace transformation on both sides, the Laplace transformation of f of t and 1 by 2 into the Laplace transformation of the two exponential functions. What is the Laplace transformation of e power minus at? E power minus at is a 1 by s plus a. 1 by s plus a. Okay. 1 by s plus, what is the a here? A is a minus j omega. A minus j omega. You know the Laplace transformation. Remember here, the Laplace transformation of e power minus at is equal to 1 by s minus a. The a value, instead of a here, the a minus j omega. A minus j omega. So 1 by 2 into 1 by s plus the a here is a minus j omega plus for the second term 1 by s plus a is a plus j omega. For the second exponential value, the power, the coefficient of the t is a plus j omega. Simplify these two. 1 by s plus a minus j omega and 1 by s plus a plus j omega. Considered as x plus a is a and the j omega is a b, a minus b and a plus b, the a square minus b square, and a square is a s plus a whole square plus j omega whole square. It is a minus into minus again plus, and in the numerator s plus a plus j omega and s plus a minus j omega. So minus j omega and plus j omega get cancelled. In the numerator, we'll get the 2 into s plus a. So 2 to get cancelled, s plus a by s plus a whole square plus omega square. Remember, my dear students, here. Now the Laplace transformation of e power minus at cos omega t is equal to, we got the s plus a by s plus a whole square plus omega square. So actually the Laplace transformation of cos omega t, what is the cos omega t? The Laplace transformation is s by s square plus omega square. So the Laplace transformation of cos omega t is a s by s square plus omega square. Now it is multiplied with the e power minus at. E power minus at. What is the e power minus at? The Laplace transformation is 1 by s plus a. 1 by s plus e power minus a. So the term s is changes as s plus a when the negative exponential is multiplied with the cos omega t. Understood, my dear students? The cos omega t, the individual, the Laplace transformation is s by s square plus omega square. Now, to find the Laplace transformation of e power minus at cos omega t, since the e power minus at, the Laplace transformation is 1 by s plus a. So wherever the s is there, you now change that is a s plus a by s plus a whole square plus omega square. Okay. Similarly, the Laplace transformation of sine omega t is omega by s square plus omega square. The last class we already discussed about the Laplace transformation of sine omega t. Now, what is the Laplace transformation of e power minus at sine omega t? Wherever the s is there, you can replace by the s plus t. So omega by s plus a whole square plus omega square. Got it, my students? In a similar way, we already know. Now, what is the Laplace transformation of e power plus at cos omega t? E power plus at. What is the Laplace transformation of e power plus at? Plus at is a 1 by s minus a. 1 by s minus a. So wherever it is a s, we have in the Laplace transformation of cos omega t, I can keep the s minus a by s minus a whole square plus omega square. In the similar fashion, the Laplace transformation of e power plus at sine omega t is equal to, it is a s here in the Laplace transformation of sine omega t is a omega by s minus a whole square plus omega square. Got it, my dear students? If you know the Laplace transformation of e power minus at and the Laplace transformation of e power plus at, and after knowing that is a Laplace transformation of cos omega t sine omega t, to find the Laplace transformation of the product of the two functions, e power minus at cos omega t, e power minus at sine omega t, and e power plus at cos omega t, e power plus at sine omega t, wherever the s is there, you can change that s as s plus a when it is multiplied with e power minus at. Wherever the s is there, you can replace the s minus a when it is multiplied with e power plus at. Got it, my students? These are all, it is a online bits only. But if you given the part A as your external examinations of 3 marks questions, these are. Got it, my students? Now coming to the another example, determine the Laplace transform and ROC for the signal. ROC for the signal e power at mu of minus t. E power at mu of minus t. And this e power minus e power at. See, the minus is also there. Total function is a minus, not in the power here. Minus e power plus at mu of minus t. I got the definition of the Laplace transformation. X of s is equal to integral minus infinite to infinite x of t e power minus s t dt. What it difference? Now, in this example, you have to find out the Laplace transformation of the given signal x of t is equal to integral minus infinite to infinite minus e power at mu of minus t into e power minus st dt. Got it? So mu of minus t is a folded function of the step. Step function is varies from the 0 to infinite. Mu of t and mu of minus t is a folded function. So it is varies from the minus infinite to 0. Magnitude is the same for both the mu of t and mu of minus t, but it is a folded at the 0, mu of minus t. So now we can change the limitations from minus infinity to 0 by replacing the mu of minus t is a 1. So integral minus infinity to 0 minus e power at e power minus st d is equal to, now both the bases only, we can add the powers here. Minus is already there. Minus infinity to 0 e power, take the minus s minus a into t dt, that is equal to, what is the exponential integral here? E power minus of s minus a into t by minus of s minus a, because it is a coefficient of t. We are applying the integral with respect to the t only. Upper limit is a 0 and the lower limit is a minus infinite, and the total function having the minus. Got it? So this a minus and minus becomes a plus. Minus into minus is a plus. Upper limit is a 0 and lower limit is a infinite. Upper lower limit value e power infinite is a 0 and upper limit e power 0 is a 1. So 1 by s minus a. So this is for exponential positive. The Laplace transformation, that is equal to 1 by s minus a. Got it, students? So for positive exponential value, 1 by s minus c. Now only we see, and negative exponential value is a s plus a. But what is ROC here? The ROC is very important. The region of convergence, whenever it is multiplied with the mu of minus t, mu of minus t. So mu of t also will get the same thing. Mu of t is also will get in the same thing without any minus here. E power at mu of t, you can find the Laplace transformation. We'll get the 1 by s minus a only. But here the mu of minus t, the ROC is s minus a. S minus a is because it is the minus 0 to the infinite, it's a less than value. Okay. See, we got x of s is equal to 1 by s minus a, and s minus a is a less than the 0. Why it is a less than the 0? Because the t tends to the minus infinite to 0. We are taking the limitations is from the negative real axis. So negative real axis, s is less than a. S than a towards the negative real axis. Totally, this is a shaded area what we have here, less than the a. The ROC, the region of convergence. If s is greater than a means in the positive real axis. So minus infinite to the value up to the positive plus a, all the values is existed for the function what we are taking, the e power at mu of minus t minus value. Got it? Minus e power at mu of minus t, the Laplace transformation is 1 by s minus a, and its opposite is s is less than a. Why we are taking the s is less than a? Because of applying the limitations here. You are taking the integral limitation minus infinity to 0. So it is a less than the plus a. Got it, my dear friends? The Laplace transform will coverage if S is less than A. For S is greater than A, the integration will be the unbounded. When it is bounded, when we take the values is S is less than E, it is a shaded area towards the negative real axis. If any value you can take below the values of plus A, it is bounded. You can take any values of greater than the A values, it is unbounded. S is greater than A, the integration will be unbounded. Okay, you can call it as it exists for all the values of S from minus infinity to plus A, the Laplace transformation is exists. Otherwise, it is not exist. Nothing but is bounded and the unbounded values. Remember, for e power plus a t mu of minus t. What is the ROC? The difference here, if I explain x of s, and now I'm taking the x of t is equal to e power a t mu of t. E power a t mu of t. X of s is equal to integral minus infinite to infinite x of t e power minus st dt. Okay, I'm taking here now this is mu of t. The limitations now stored here, the e power minus integral minus infinite to infinite x of t is e power a t mu of t into e power minus st dt. Mu of t is equal to 1 in the ranges of 0 to infinite. So e power a t, e power minus st dt. Got it? Now the basis of the same, you can add the power e power minus, you can take s plus or the s plus s minus a into t. Now it is e power minus st and e power plus a t. And integral 0 to infinite. With respect to the t, we are applying the integral for the exponential. Okay. So what is the integration for exponential e power minus x of minus a into t by minus s minus a. Now upper limit is infinite and lower limit is 0. When you substitute the upper limit, it becomes of 0 minus, and lower limit you can substitute as a t, e power 0 is a 1 by, and in the denominator we have the minus of s minus a. Minus of s minus a. Minus and minus get cancelled, is a value is 1 by s minus a. When we can take the Laplace transformation of e power a t mu of t, the value is the same for s minus a. Even the Laplace transformation minus e power a t mu of minus t. But this Laplace transformation is also the same, s minus e minus e. But what is the difference? ROC is the difference. What is the ROC for this one? ROC is greater than. Why you are taking the greater than? It is a t values is varies from 0 to infinite. The ROC is greater than a. The region of convergence greater than a. The graphical representation is totally the above values. The Laplace transformation exists. S values is greater than the a. And coming to this one, the ROC is S is less than e, and the Laplace transformation is bounded for the values of S is less than e, in between of minus infinity to a values. Okay, for this reason, we have to see what is the ROC of the given function in the time domain functions. With ROC only you can find out the inverse Laplace transformation. So if it is S is greater than a, the inverse Laplace transformation of by s minus a is e power a t mu of t. And 1 by s minus a, what is the inverse Laplace transformation is e power minus e power a t mu of minus t. When when the ROC is S is less than E. Without knowing this ROC, S is greater than E and S is less than E, it is somewhat difficult to write the inverse Laplace transformation, for which value it is 1 by S minus E, and here also 1 by S minus E. And what is the inverse Laplace transformation? It is the e power at mu of t r minus e power at mu of minus t. We don't know. With this ROC only, we can justify that for 1 by S minus E, what is the inverse Laplace transformation? For which values of S, the Laplace transformation exists. That is, depends upon the ROC only, the region of convergence. Got it, my dear students? Okay. Coming to the next one, the relation between Fourier transform and the Laplace transformation. Relation between Fourier transform and the Laplace transformation. We know the Fourier transformation is given as x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. The Fourier transformation can be calculated only if x of t is absolutely integrable. This is one of the ROC of the Laplace, not the Laplace, Fourier transformation. We can call it as a discrete conditions. That is the first one. It is absolutely integrable. Finite discontinuities, finite maxima and minima, and single valued property, and absolutely integrable. These are all, it is the conditions, the necessary and sufficient conditions for the Fourier transformations and the Fourier series also. Discrete conditions we are calling it as. So in that, the one of the condition is absolutely integrable, integral minus infinite to infinite, the magnitude of x of t dt is less than infinite. We know that S is equal to sigma plus j omega, where sigma is a real term and the j omega is an imaginary term. We can substitute in the definition of the Laplace transformation, x of S is equal to minus infinite to infinite x of t e power minus st dt. On the definition of Laplace transformation, x of S is equal to minus infinite to infinite x of t e power minus s into t dt. What is the S here? Sigma plus j omega. Integral minus infinite to infinite x of t e power minus of sigma plus j omega into t dt. Got it? That is equal to integral minus infinite to infinite x of t, expand these two or split the two parts as e power minus sigma into t as of one function and e power minus j omega t dt. You can see these two equations. X of j omega is equal to integral minus infinite to infinite. Instead of x of t, here it is multiplied with the e power minus sigma into t. E power minus j omega t and e power j dt is the same. Okay, so comparing the above equation with the 2.6, we find the Laplace transformation of x of t is basically the Laplace transformation of x of t is basically the Fourier transformation of the signal x of t e power minus sigma t. The Laplace transformation of x of t is basically the Fourier transformation of x of t e power minus sigma into t. If x is equal to j omega, you see it. If x is equal to j omega, that is sigma is equal to 0 in the above equation. S is equal to j omega means sigma is equal to 0 because here the S is equal to sigma plus j omega. Integral minus infinite to infinite x of t Sigma is equal to 0 means e power 0 is a 1. E power minus j omega t dt. So you can replace the s as x of j omega, and sigma is equal to 0 here. At sigma is equal to 0. Now both the equations are the same. X of j omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. So x of s is equal to x of j omega. X of s is equal to x of j omega. X of s is a Laplace transformation and x of j omega is a Fourier transformation. This means the Laplace transform is same as the Fourier transform. Same as the Fourier transform when s is equal to j omega. The above equation shows the Fourier transform is a special case of a Laplace transform. Thus, the Laplace transform provides a bordered characterization compared to the Fourier transformation. S is equal to j omega indicates imaginary axis in complex explain. Thus, the Laplace transform is basically a Fourier transform on imaginary axis in the S-plane. Got it, my dear students? What is the conclusion here? The relation between the Fourier transformation and the Laplace transformation is the Laplace transformation is basically a Fourier transform on imaginary j omega axis in the S-plane. On imaginary j omega axis in S-plane. Okay. Convergence of Laplace transformation. What is a convergence here? Previously, we are saying this is a convergence in the Fourier transformation is one of the discrete condition, absolutely integrable. Now, because of the relation is there with the Laplace and the Fourier transformation, the Laplace transformation is also convergent. For the signal x of t e power sigma t, the dt is less than the infinite. For the equation, we know the Laplace transformation is basically the Fourier transformation of x of t e power minus ut. Hence, if Fourier transform of x of t e power minus sigma t exists, then the Laplace transform of x of t is exist. For Fourier transform to exist, x of t e power minus sigma t must be absolutely integrable. Must be absolutely integrable. Got it, my dear? Simply, we can say that is s is equal to j omega. The Fourier transform Laplace transformation is becomes to the Fourier transformation, or otherwise, the signal x of t e power minus sigma t. That sigma is a real axis. Is a Fourier transformation of Laplace transformation of the signal x of t e power minus sigma t. Or the Laplace transform is basically a Fourier transformation on the imaginary axis in the S-plane. Since the sigma is a 0 there, a point on the imaginary means a real term is a 0. A point on the real means imaginary axis is a 0. Got it, my dear students? Okay. Now, another examples you can see. We already seen the calculate the Laplace transform and ROC of e power minus ut mu of t 1 by s plus c, and ROC is s is greater than minus e. S is greater than the minus e here. The shaded area is a minus e, and in the similar fashion is a positive and the negative. and we have already the properties we discussed. See, one of the property we are not discussed is a time scale. So ninth one is missed there. After the 8th, we go on for the 10th one. And another two properties are not we discussed here. The time scaling, if Laplace transformation of x of t is x of s, then the Laplace transformation of x of at, 1 by a, the magnitude of a, and the x of s by a. So we got the definition of the Laplace transformation. We got the definition of the Laplace transformation. I'll explain here. So one of the property what we missed in the earlier, that is a ninth property. The Laplace transformation of x of at, scaling property. We call it a scaling property, is equal to 1 by the magnitude of a and x of s by a. Okay, what is a scaling property? And this property is also we already discussed in the Fourier transformation also. Fourier series proof, not the solution, it is proof. You got the definition of a Laplace transformation. X of s is equal to integral minus infinite to infinite x of t e power minus st dt. We need to find the Laplace transformation of x of at is integral minus infinite to infinite. Substitute that x signal, the time domain signal, x of at e power minus st dt is equal to, now assume at is equal to some m and t is equal to m by a, and apply the derivative with respect to on both sides. So dt is equal to 1 by a into dm. Now you can replace here minus infinite to infinite x of at x of at is equal to m e power minus s, t is equal to, now it is m by a into dt, dt is a 1 by a into dm. Okay, now write the 1 by a outside, 1 by a. Now it is in the form of integral minus infinite to infinite x of m e power minus s by a whole multiplied with m into dm. Now observe here the definition of the Laplace transformation, and here the x of m and e power minus s into m and dm. Instead of s, it is s by a, and the t is with the dummy variable of m. Now if it is a e power minus st, the Laplace transformation is x of s. Instead of s, it is s by a. It becomes of 1 by a x of s by a. You can take it as a magnitude s of a. So the scaling property saying the Laplace transformation of x of t is equal to, x of at is equal to 1 by a, the x of s by a. Got it, my dear students? Now that is one of the property we missed in the previous. Already discussed the linearity property, time differentiation property, time integration property, frequency shift property, time shift property, frequency differentiation property, and frequency integration property, and the other one is a time scale. Okay. Periodicity property also. Periodicity property. About the periodicity property, if x of t is equal to x of t plus n into t as a continuous time function, n is any variable, x of t plus n into t. Periodic with the period of t, it is a repeated the intervals. And x1 of t is a one period of x of t. And the Laplace transformation of x1 of t is x1 of t e power minus st dt. And in the range of 0 to t only, because it is a periodic product. Within this period only, the value is repeated. Then the Laplace transformation of x of t plus n into t, when the t changes with the n plus t is added, it becomes of 1 by 1 minus e power minus st, and the same function, integral 0 to t x1 of t e power minus st dt, nothing but x of s or x1 of s. Got it, my dear students? Okay. Now, using that it is a Laplace transformation of x of t plus n into t is 0 to infinite x of t plus n into t e power minus st dt, and it is varies only the repeated functions from 0 to t e power minus st when n is equal to 0, and n is equal to 1, it is varies from the t to t because it is a repeated again, and n is equal to 2, it is changes from the 2 to 3t, 2t through 3t is for every t variables, the n is changes, this goes on added for the 2t, 3t and 3t, 4t and so on the value. The last function is n into t, n plus 1 into t. Or we can take it as a t minus 1 into t or n minus 1 into t is n t up to the value of so on the infinite, because of the we can take it as a repeated up to the infinite. Periodicity means always it is a repeated at regular intervals of 0 to t, t to t, 2t, 2t to 3t and so on. And this, all the sum of values you can write as sum of p is equal to 0 to infinite. P is equal to 0 to infinite. P into t up to so on p plus n into t, because it is increases up to the t value. So p is a one term and the p plus 1 into t. 2 plus 2, t plus 2, and 2t to 3t is one value is increases in the upper limit. So p into t, p plus 1 into t, x1, the t minus, it is a minus, why I have the minus, it is not the minus, my dear students, it's a plus only. T plus in p into t, e power minus s into t plus p into t. Okay, the t values changes here as t plus p into t and the t plus p into t dt. Don't put here the t plus p into t because it is a variable of. Got it? The sum of p is equal to 0 to infinite, integral 0 to t, x1 of t e power minus st and e power minus p into s into dt. Why I am replacing this x of t plus pt is x1 of t? The condition is given here. The condition is given, it is a periodic signal. Okay, it is not the pt plus, my dear students, it is a plus. So x1 of t, because x of t is equal to x of t plus n into t. Now the variable is a p here, 1 and 1. So x1 of t is equal to x1 of t plus p into t. Okay, so I replace x1 of t plus pt as a x1 of t because it is a periodicity obeys e power minus st and e power minus ps into t. That is equal to integral 0 to t x1 of t e power minus st, and we have only the p in this expression, sum of p is equal to 0 to infinite e power minus p st into dt. Got it, my students? And integral 0 to t x1 of t e power minus st dt you can write as one function, and the sum of p is equal to 0 to infinite e power minus p st. Now expand this function as e power p is equal to 0 means 0 minus plus e power p is a 1 now, 1 into st plus e power minus 2 into st plus e power minus 3 into st and so on. It is nothing but you can assume it is a value e power minus power 0 and e power minus st and another one is e power minus t whole square and so on. So a power 0, a power 1 and a power 2 and so on means 1 by 1 minus a. 1 by 1 minus a. What is the a here? E power minus st. E power minus st. I already told that is the sum of n is equal to n1 to n2. A power n is equal to. So the a power n means e power st whole power p value. The value is a power n1 minus a power n2 plus 1, n2 plus 1 whole divided by 1 minus a, and a is always less than 1 and n2 is greater than the n1. This is a formula here. What is the value of n1? 0. So substitute the a as a power 0 minus what is the n2 infinite? A power infinite plus 1 and whole divided by 1 minus a. That becomes of a power 0 is a 1 and a power infinite is a 0 and 1 by minus a is equal to 1 by 1 minus a. Is the same thing. Here it is a value is e power st is equal to that of sum of p is equal to 0 to infinite e power st whole power p value. So n is equal to n1 to n2 a power n and p is equal to 0 to infinite a power p1. So it is multiplied with 1 by 1 minus e power minus st and this function. So for a periodicity property saying that 1 by 1 minus e power minus st is a capital letter, my students, not the small letter here. St multiplied with the integral 0 to t, nothing but x1 of s, the Laplace transformation. Got it? So periodicity property. The total function we can conclude it as x1 of s and this also x1 of so. Got it? That is one of the other property we missed in the previous. Inverse Laplace transformation. Now go for we completed the examples of Laplace transformation. Let us see, before going to the inverse Laplace transformation, is there any other examples of the Laplace transformation? Okay. Now here some of the examples, a Laplace transform of certain signals using waveform synthesis. Using waveform synthesis. Our examples also we have so many. The waveforms. After completing these examples of the Laplace transformation, in the next class we go for the inverse Laplace transformation. So here the given the signal is in terms of the waveform or it's a graphical representation. Find the Laplace transformation using the definition. Given here the x of t signal is a square wave with 0 to capital T, and the positive cycle is from 0 to T by 2, and the negative half cycle is T by 2 the T. And amplitude is A for positive cycle and the minus A for the negative cycle. So the x of t is equal to A for the range is from 0 to T by 2, 0 to T by 2, and x of t is equal to minus A for T by 2 to the T, T by 2 to the T minus A, because it is a negative amplitude and here it is a positive amplitude A. For the given graphical representation, we wrote the mathematical expression x of t is equal to A and x of t is equal to minus A. I want the definition of the Laplace transformation x of t is equal to x of s, that is integral minus infinite infinite x of t e power minus st dt, and the range is only from 0 to t, the remaining all the values is a 0. I change the limitation from minus infinite to infinite as 0 to t, x of t e power minus st dt. And in this range also, the two values we have, one is from 0 to t by 2, the magnitude is a e power minus st dt, and another range is there t by 2 the t, in that the magnitude is minus a e power minus st dt. Okay, so now apply the integral for this one, e power minus st by minus s, with upper limit is t by 2 and the lower limit is 0, and e power minus st by minus s, with upper limit is capital T and the lower limit is capital T by 2, and that is equal to, substitute the upper limit as in the t, a into e power minus s t by 2 by minus s, and for the lower limit we can get the negative value, a into e power 0 by minus s, plus for the second term also you can apply the upper limit, a into e power minus s t by s, and lower limit is a into e power minus s t by 2 by s. A simple simplification of mathematical expression only. After substituting the values here in the definition of the Laplace transformation for the given waveform, a simple mathematical simplify the mathematical expression. E power 0, we know the one, a by s, and here also the e power a into e power minus s into t by 2 the by s, minus value, minus into minus is a plus, a by s, and a by s e power minus st, and here the minus a by s into e power minus st by 2. Simplification. Take all the terms, see the four terms having the a by s is a common, a by s, and 1 minus e power minus st by 2, we wrote it is a square term. How it is a square? You can see e power minus st can expand the function 1 whole square plus e power minus st by 2 whole square minus 2 into e power minus st by 2. This is after expanding of a minus b whole square formula. 1 plus e power minus st by 2 whole square means 2 get cancelled. It becomes of e power minus st minus 2 into e power minus st by 2. So see whether there is any equations or there in this equation. So minus 2, here the minus a by s and here the minus a by s. Both the exponentials are same. So 2 into e power minus st by 2 for these two terms. And a by s you can take is a common, the one value we got here. And a by s you can take the common, e power minus st. So you can write as the above equation is a by s into 1 minus e power minus st by 2 whole square. Got it, my dear students? In this way, we can solve the given Laplace, given the waveform synthesis or the waveform or graphical representation is given, you can write first of all the mathematical equation in terms of x of t or the x of t in terms of the given amplitudes and substitute in the definition of the Laplace transformation and solve or simplify the equation. You get a by s into 1 minus e power minus st by 2 whole square. And coming to the second one here, the b, a gated function given from 0 to a, the magnitude is 1, the signal x of t. So x of s is equal to, I'm directly writing the values from 0 to a. The x of t is nothing but 1 e power minus st dt. What is the e power minus st? The integral e power minus st by minus s. Upper limit is a and lower limit is 0. That is equal to minus 1 by s into e power minus s a minus 1. Because e power 0 is a 1. Multiply this a 1 minus the term. It becomes of 1 by s into 1 minus e power minus s is equal to 1 by s into 1 minus e power minus s. Got it? So here the same thing, 1 by s into 1 minus e power minus a into s. Coming to the next one, given the graphical representation is a ramp function from 0 to a, from 0 to a. First of all, you can find the quadrants at here, at p value there is a 0, 0. And here the value is a into 0 because the a is the x value and here also the a. Two functions. Because it is a 0, a point on the real axis means the y is also the 0 and the x is a 0 here. X is 0 and y is 0. Means x1 and y1. And coming to the second point, second quadrant, x value is a and the y value is also a. At a, the y value is a. So a comma a. x1 y1 and x2 y2. x1 y1 and x2 y2. On the straight line equation, we know the y minus y1 is equal to m. M means y2 minus y1 by x2 minus x1 into x minus x1. What is the y here? The given signal x of t. Y, x of t signal. X of t minus y1 is a 0 is equal to y2 is a minus 0 by, and what is the x here? The t value. The t minus x1 is a 0. Not it is a x2, my dear students. It is a x2. x2 is also a. And now here it is a x. X is a t minus x1 is a 0. So x of t is equal to, is a 0, there is a by a is a 1. 1 into t minus 0. So x of t is equal to t. X of t is equal to t. So far, the given graphical representation, what they given, the signal x of t is equal to t, my dear students. X of t is equal to t in the range of 0 to a. And 0 for t is greater than a. T is greater than a value. Now can substitute in the Laplace transformation definition, x of s, saying that integral minus infinity infinite, x of t e power minus st dt. E power minus st dt. What is the range here? From 0 to a only, the x of t value is a t into e power minus st dt. I can apply the integration by parts. What is the integration by parts here? The t, first of all, you can take the t and apply the integral for the second term. Minus e power minus st by minus s. Minus, take the integral and apply the derivative of first one, 1. And apply the integral here, e power minus st by minus s into dt. and the limitations here 0 to a. And again inside we can take the t e power minus st by minus s, minus into minus is becomes is a plus. Again apply the integral here, e power minus st by minus is there. Again already we have the 1 by s is there, 1 by s minus s with upper limit is a and lower limit is 0. What it minus students? Now substitute the a value. Substitute the a value for these two terms wherever the t is there. A into e power minus s into a by minus s. And here the minus value 1 by s square into e power minus s into a for these two terms. To substitute the lower limit, get it is of minus, it becomes of plus, t is a 0, and the minus is already there, that is also will get the plus now, 1 by s square, because e power 0 is a 1. Okay, now what is the expression we got? 1 by s square minus 1 by s square into e power minus sa, and the minus 1, not the 1, a by s e power minus sa. What did find, students? The final answer we got 1 by s square, 1 by s square into e power minus a minus a by s. You take the common of 1 by s square, my dear students, here. 1 by s square, it becomes of 1 minus e power minus as. And here only the one s is there. Now can multiply the s in the numerator, sa into e power minus s. A. The final answer we got is 1 by s square into 1 minus. In these two terms also the common term is e power minus a into s. Take the minus 1 plus s into a. What it matters. So like that we can find out the Laplace transformation for the given graphical representations. Got it? And some more examples that determine the Laplace transformation of continuous time signal and their ROC. X of t is equal to a into mu of t. You know the mu of t, the Laplace transformation is 1 by s. 1 by s. And here the ROC, we know the Laplace transformation of 0 to infinite, x of t is a is a magnitude, 1 is a mu of t and e power minus st dt, my students. Because why I am taking the 0 to infinite, the mu of t varies from the 0 to infinite only. A into e power minus st by minus s, with upper limit is infinite and lower limit is 0. A into upper limit is 0 when I am substituting the upper limit, and minus 1 by minus s divided by a by s is a Laplace transformation. And what is the ROC here? S is greater than the 0, because mu of t here, whenever there is a mu of t, you can take the denominator expression is a greater value. Whatever the expression is there in the denominator, you can take the greater value, greater than the 0. If it is a mu of minus t, you can take it as a s is less than the 0. Why I am taking the s, not the s? It is a denominator factor. Whatever the factor is there in the denominator, that is less than the 0 when mu of minus t, negative real axis. Now it is a positive real axis, you can take it as a greater value. So given signal a into mu of t is a Laplace transformation is a by s, and with the ROC as all points in the S plane to the right at line passing through the sigma is 0. This total region. The ROC is a region here, and SC is greater than the 0. SC is greater than the 0. ROC is right off of the S plane. Right off of the S-plane is ROC for the given mu of t. If mu of minus t means ROC is the left half of the S-plane. Left half of the S-plane. Total ROC, left half of the S-plane. Okay, my dear students. The next is x of t is a t into mu of t. T into mu of t. When every time it is t is multiplied, the Laplace transformation, we already know the Laplace transformation of mu of t is 1 by s. When the t is multiplied, the t into mu of t, it becomes of square, 1 by s square, the t into. Got it, my dear students? So means the t power by 1 factorial. The same thing when the Laplace transformation is for the t square by the 2 factorial into mu of t, it becomes of 1 by s cube. And similarly, the Laplace transformation of t cube by 3 factorial, nothing but the 6 mu of t. What is the Laplace transformation? 1 by s power 4. Means 1 it is increases, here also 1 is increases. So becomes of the Laplace transformation of the t power n plus 1, not the n plus 1, t power n, t power n by n factorial mu of t. What is the Laplace transformation, my dear students? 1 by s power n plus 1. Because here the n, it is n plus 1. So 1 is there, n plus 1. 2. 2 is there, it is a cube. 3 is there, it is a 4. So n we have n plus 1. So generic value 1 by s square. Got it, my dear students? And another example we can see e power minus 3t mu of t. E power minus 3t mu of t. For mu of t, we know the 1 by s. And it is multiplied with the e power minus 3t. E power minus 3t. So here, integral 0 to infinite x of t e power minus st dt is the definition of the Laplace transformation. And given the term is mu of t, because it changes already there, 0 to infinite e power minus 3t. Both the bases are same, e power minus s plus 3 into t. And simplify, after applying the integral of exponential value, we'll get 1 by s plus 3. 1 by s plus 3. Simple, we can say the e power minus at mu of t. What is the a here? 3. We know the Fourier transformation of e power minus at mu of t. Mu of t is 1 by s plus a. What is the e power minus at is given now? It is e power minus 3t mu of t. They're asking. This is 1 by s plus 3. So s plus 3 is greater than the 0 because of mu of t here. So s is greater than minus 3. So from minus 3 is ROC is there. From minus 3, the total region is ROC. For all the values of above the minus 3, the Laplace transformation is convergence or bounded, or we can say it is exists. Got it, my dear students? The similar fashion, e power minus 3t mu of minus t. E power minus 3t mu of minus t. The Laplace transformation is the same, s plus 3 only. For the Laplace transformation of e power minus 3t mu of minus t, the Laplace transformation is the same. But what is ROC for the mu of minus t? Is s plus 3 is less than the 0, my dear students. So s is less than minus 3. So what is the region of convergence? Minus 3. So minus 3 is here. The region of convergence is from left side. ROC is from infinite to the 3, in between of minus infinite to the minus 3, not the 3, minus 3. Got it, minus? For this reason only, we need the region of convergence. And you can apply the inverse Laplace transformations. So here, the range of the shaded region is from negative real axis. The same thing we got 1 by s plus 3, 1 by S plus 3 because it's a mu of minus 2, you'll get the minus values there. And that sigma is a minus 3. The region of convergence is totally in the left hand side. Got it, my dear students? Totally in the left hand side. And remaining we can see in the later, my dear students. So that is e power minus mu of cap magnitude of t. E power minus mu of magnitude of t. We can discuss in the next class. Okay. Any doubts? Okay, thank you.